Building a healthy home. Building and renovating can be an exciting time, but it shouldn't come at the cost of their occupants' health, which unfortunately much of the time it does. Despite the fact that we spend 90% of our time in a building, very few people are aware of the hazards that exist. So for this subject, what I wanted to do is to look at the primary principles on building a healthy home. All of this is available through my book, Healthy Home, Healthy Family, in Chapter 6. And it will provide the latest evidence as to why we need to follow some really basic principles. The first problem we find with a lot of new homes, especially in cool or warm temperate climates, is the development of condensation and mould-related problems. Recent studies by Dr. Tim Law from the University of Tasmania has documented significant condensation problems in 40% of new builds in Tasmania. That is staggering. And we will look at why that is happening and what needs to be done to reduce exposure and the development of condensation. We know many homes require significant maintenance within 30 years. You contrast that to many of the houses in Europe that are standing after 700 years, and we'll have a look at why this is also a problem. There's a high level of chemicals outgassing. These are primarily semi-volatile organic compounds. These VOCs persist for years, and because of the compromise in passive ventilation as a result of the new star energy ratings, our exposure to these chemicals has increased significantly. We rarely consider the microclimate that a house is built. So we pick a house off the plan from a display village and we plonk it onto the block of land we've just bought. This is a disaster because it doesn't take into consideration the unique microclimate of that area and especially of that specific local area. We'll talk a little bit about the microclimate, and you will go into detail on this in both this subject and of course in building materials. Australia is incredibly unique. It is such a huge land mass with over seven climates and various microclimates within those. So as a result of this, we're exposed to almost every type of climate that you'll find on this planet. The use of poor building materials or poor workmanship is something that we're all familiar with. We've heard about disasters and builders who don't do the right thing, who don't follow the building code, and you know, it's one disaster after another, and the client is left with a home they often can't live in, and it goes through VCAT or legal ramifications for years, which is just awful. Insufficient ventilation. Our push towards 8-star or more energy rating homes has resulted in developing plastic bags that can't breathe. And even though it might be good for sustainability and energy efficiency, it's not necessarily good for occupant health. And of course, this is why in these subjects, building materials and building design, the primary focus is what impact does it have on human health and how do we create environments that support people's mind, body and soul. Exposure to hazards that are known to cause health problems, and there are many of them, and we'll focus on that shortly. So the key principles, as I mentioned, are outlined in my book, Chapter 6, Building and Renovating, with all the latest evidence, and that's what I'll go through. So for more reading, go to that chapter. The first of those is location. Location, location, location. You hear it by all the real estate agents. If you get this right, you can the clients can reduce their exposure to man-made chemicals by at least 50%. So it's important they engage your services before they even buy the block of land, because where they live, they could be exposed to numerous toxicants from traffic-related air pollutants, mining, being on a flight path, coal seam gas exploration, wind turbines, high voltage transmission lines, power lines, you name it. There are so many potential hazards that can impact a site before you even build it, and that's why I spent a lot of time on that, understanding those exposure zones as part of my PhD. Identify the health hazards prior to renovating it and demolishing the home, important. Asbestos, lead dust, synthetic mineral fibres, treated timbers. Prevent condensation and mould related problems. A lot of evidence coming out now as to what we need to do in order to prevent condensation in a new build. Minimise exposure to harmful electromagnetic fields. I'll go through some of those principles here, but most of it will be covered in the electrobiology subject. Minimise exposure to harmful toxicants. Toxicants are man-made chemicals. Choose heating and cooling systems suitable for allergy sufferers. As I say, you either get a filter or you be the filter. Choose healthier lighting options. Many lighting options are a disaster for people with electrical sensitivities. The compact fluorescent light bulbs, fluorescent tubes are just a nightmare. So we'll look at healthy options. Integrated pest management. There's lots of great websites around the world on how not to use chemicals for pest management and use other things like physical barriers instead. So let's get to it. Location, location, location. A few hours or a few days researching the location of the site to potential hazards is worth its weight in gold. The client is about to spend hundreds of thousands of dollars, their life savings, on a block that potentially could be a disaster for their health, especially if they already suffer from asthma, allergies, cancers, any form of chronic illnesses, learning and behavioural disorders in their children. Like, it doesn't matter how well the house is built, how healthy the home is, if the area is exposing them to hazards, then there's no point putting all that effort into building a healthy home. Research the past and current use of the land. In Melbourne, most of Melbourne was used as orchards in the 50s and 60s, and of course we dumped tons and tons of organochlorine pesticides. So as a result of that, soil testing is really important. I know it is mandatory before building anyway, it's a good thing, but they are still breaking down in our soils decades later. So knowing if that site was a petrol station and now it's a housing development is a problem. Knowing that it was a waste site or a dump or a sewage plant or used for industry where toxic chemicals were buried, you want to know that information, and that's an important part of your research as a building biologist. The site should be amidst green areas. The more greenery there is, especially with large broadleaf plants, the healthier it's going to be, because the plants will act as a filter. They will be the filter for you. And that's why I live and work in Warrandyte. We are the closest national park to the city of Melbourne, and there's over 583 million hectares around this area. They are the lungs so that my lungs don't have to deal with a lot of that pollution. And of course there's no major arterial routes coming through this suburb, which is why it's an area that I love. Avoid geopathic stress. That is taught in the geobiology subject. I understand some of you may not choose that as your elective, that's fine, but it is important that you get a geomancer or a building biologist who has done the subject in order to identify geopathic stress, to make sure the house isn't built above fault lines, ley lines, underground watercourses, aquifers, or Aboriginal sacred sites. I don't want to get too esoteric here, but in sacred space, which is a subject in the Feng Shui course, we'll go into the impact of sacred sites on human health. It is esoteric, but having had quite a bit of experience with people who've built, including my own first time on an Aboriginal sacred site, I would strongly suggest you research this so that your clients don't build on these sites, because weird stuff does happen. Of course, not building above radioactive deposits. In the electrobiology subject, we'll point you to websites that will enable you to assess the site for thorium, potassium and uranium. They are throughout Australia. There are many hotspots throughout Australia that are highly radioactive, and if clients live above these spaces, they increase their risk of exposure to radon gas and lung cancer, radon is actually the second most common cause of lung cancer in the world after cigarette smoking. So you don't want clients building above granite, phosphate rock, or any other form of radioactive deposit. Avoid building on flood or industrial zones for obvious reasons. Identify exposure zones. This is a pet topic of mine because I spent a lot of time looking at geomedicine in the PhD. And here is a list of various hazards likely that could be affecting the block of land or the site and the exposure zones. This only took me about 3 months of research, and a lot of the evidence for that can be found in my book Healthy Home, Healthy Family. So power lines, street power lines, which are more adequately described as distribution lines, should be at least 5 metres away from the home. If there are transformers, which are boxes on the power line, then you want at least 6 to 7 metres away from the site. from where the house will be built. Tram lines, again 5 metres. This is a huge problem in Melbourne where we have a lot of tram network. You've got places like Armidale, Malvern, Brunswick, which can be just metres, second floors can be just metres away from these tram lines. Very high levels of AC electric fields, very high levels of AC magnetic fields, to the extent where all the testing that I've done in these homes, the first room closest to the lines are very high in electromagnetic fields, and I strongly suggest people don't use them. Use them as storage spaces or guest bedrooms instead, but don't sleep in them, because you can't shield against the magnetic fields. The other problem with these lines is that because the electric field is so high and you've got roads directly beneath them, you've got high levels of traffic-related air pollutants sticking around these lines, around the corona. And of course, when you open your windows on the second and third floor, you're inhaling these charged particles, which are incredibly toxic to the lungs. So workplaces and people sleeping in these environments should actually have air purifiers in these rooms, and of course not spending too much space in the room closest to the tram lines. Cell phone towers or mobile phone towers, the exposure zone is 400 metres. We'll go into detail on this in the electrobiology subject. The way in which the beam works on the mobile phone tower is, here's the tower, the beam will come down between 200 and 400 metres to the ground. Of course, this is in an open field. The reality is you have buildings and you have trees and you have everything in between. So it's impossible to assess what exposure that tower will have on your client's home, especially if they're still building around the area, because the homes can influence reflection and refraction of these radio frequencies, and that's why we need to use our meters. Traffic-related air pollutants living within 500 metres downwind from high-level traffic, or any traffic that stops and starts, such as a level crossing or traffic light, is a problem. In these cases, you recommend, especially if they have asthma and allergies, not to live within 500 metres downwind from these sites, certainly not within 200 metres from the area. If this is not possible, then you're going to have to implement engineering controls like air filtration systems and closing windows during peak hour traffic, etc. High voltage transmission lines, the exposure zones are anywhere from 200 metres to 600 metres. The AC magnetic fields will vary depending on the level of current and flowing through the fields. Again, like tram lines, the corona or field, the electric field around them, can attract a lot of charged particles from air pollution, from traffic-related air pollutants, or if it's mining or any form of air particles will be attracted to those fields or corona around the lines. And of course that means if you're living near these areas, your incidence of asthma and allergies could rise because you're inhaling charged particles. Radio and television towers, well, that can be kilometres in some cases, so it's difficult. You need to know what frequency they're using, to know what test equipment to use to check for emissions from radio and television towers. Certainly to say Hocking in the 1990s did some testing to find that an increased incidence of childhood leukaemia in children living near specific radio towers in Sydney. Coal seam gas exploration, again, living within 800 metres, they use incredible amount of toxic chemicals to obtain the gas, coal seam gas, and that is a real problem. Getting the safety data sheets can be quite difficult, but they are using a variety of different gases, which I've mentioned in my book. So you want to live at least, as far as possible away from these hazards as possible, but at least 800 metres seems to be the exposure zone. Pesticide drift, kilometres. A lot of the research is indicating that if you live within 2 kilometres of a farm, golf course, turf farm, timber plantations, it's something that surprised me. A lot of the timber plantations, like in Tasmania, for example, they'll often spray a huge amount of pesticides to kill off the wildlife before they fell the trees. So you think you live in this beautiful green area and all of a sudden you're exposed to huge amounts of toxic pesticides because they're using them to kill off the animals before they chop down the trees. 2 kilometres is the minimum distance you should be away from these sites to reduce your exposure. And of course, the reality is many of these pesticides do drift for hundreds of kilometres, but 2 kilometres seems to be the major exposure zone. Wind turbines, the infrasonic sound that occurs from the wind turbines can cause tinnitus, or is correlated with tinnitus, many ear syndrome, dizziness, I've had a few of my clients develop these symptoms living with a kilometre of wind turbines. The exposure zone from the research is about 2 kilometres or more you should live away from these wind turbines. Airports, 8 kilometres, 7 to 8 kilometres. When the plane is deaccelerating and accelerating, that's when it emits its largest amount of fuel. As a result of this, it can be 8 kilometres within the airport. So this is something I'll get my clients to consider, not to live within 8 kilometres from an airspace. Mining coal and coal-fired power stations, we're talking up to 70 kilometres exposure to the air particles. So really important to consider not living in mining towns or anywhere where there's a coal-fired power station. As a result of weather flows, you'll find that the particles that are exposed, radioactive, heavy metals, toxic metals, can be significantly high. And as a result of this, I would say don't live within 70 kilometres of a mining town. For all the latest evidence on this, refer to your manual and of course to my book. The second one is to identify health hazards before demolishing or renovating. I've mentioned these many times. Asbestos, of course, used between 1945 and 1980 for over 3,000 building material products. It was an incredible material, heat resistant, durable, strong, fabulous. Unfortunately, it came at a massive cost to human health. Asbestosis, mesothelioma, lung cancer, a real problem. Most of the time, this is not, it's unlikely to be a problem for exposure, because unless it's breakable, it's friable, unless it's tampered with, then you're likely to be exposed to the fibres. But whilst it sits in the eaves and it looks like it hasn't been damaged, or in the roof, etc., then it's unlikely to be a problem. So you need to assess your level of risk. Again, if you ever suspect asbestos in your client's home, you have a duty of care to write in your report that you suspect it's there, because you're not legally allowed to say it is, that you suspect asbestos is in the home, and they should, and refer them on to a licensed asbestos professional, like Noel Arnold, for example. Just Google who's in the area. Have that standard in all your reports. Lead dust, again, incredibly toxic. Reduction in IQ in children, learning and behavioural disorders, infertility in adults, mental illness, depression. Lead is incredibly toxic. Any home built before 1970, as a duty of care, as a building biologist, really important that you have that in your report, that you refer them on to ADRA, the Australian Dust Removalist Association Incorporation. They are specialists in removing lead dust. You can assume, or at least should test, for lead dust in the roof spaces, especially if the client stores luggage, clothes, furnishings in lead spaces or subfloors. That could be a real problem. You need to identify that in your report, even if it's not related to what you're there for, and have it in all your reports that they should consider getting it tested and removed. Synthetic mineral fibres, many of these bats are also hazardous to human health. Many of them can cause lung-related issues and silicosis. Treated timber, CCA timber, copper, chrome, arsenic, also again very toxic. Can be an issue when it's on decks or playground equipment, children's equipment, because when it gets wet, of course, it can come to the surface, and then of course you can track it into the house through your shoes and your feet. So that's something also to be mindful of. The third principle to build a healthy home is to prevent condensation and mould. Now, I've outlined a lot of information in my book and your manual on this, so please read this several times. These principles are very useful to implement at the design stage to prevent condensation related problems in your client's home. And it can be really summarised on this slide. Choose a dry site with good drainage. Install adequate waterproofing membranes and ensure good cavities in the roof space, in the subfloor, in the walls, because it's these gaps that provide a good break and ventilation. Make sure you use hygroscopic building materials. You know what that is because you've done building materials. And permeable and intelligent vapour wraps. Vapour wraps that can adjust to the climate that they're in. Permeable because they allow water vapour to move through the building envelope. Incorporate weep holes, of course that's required as part of the building code, and prevent the build-up of water vapour by ensuring that the steam generated from kitchen and cooking, from bathing, showering and from laundering, i.e. washing clothes, drying clothes, that the exhaust fans are exhausted to the exterior, not the roof space. So you have an adequate industrial sized exhaust fan with duct work that's insulated going out to the roof, out via the roof outside, really important. So site selection important. I'll go through these quickly, it's already in the book. Site the home in well, dry, well-drained soil if you can. Don't build above a watercourse. Surprising how many people do. Or of course in a floodplain. Brisbane, what a good example of a disaster. You know, council allowing people to build in a floodplain. It hadn't flooded for 60 years, yeah, but it's a floodplain. Nature doesn't go, well, it's time to flood, I'll do it now. It just does it ad hoc. It is a floodplain, full stop, don't build. Don't build on or into a hill. Big problem with a lot of the homes in Sydney. They're built into sandstone, granite, real issue for water drainage. Prepare the site so that water diverts away from the home. You really can't spend enough time doing this properly. Make sure you get a drainage consultant involved at the building stage to make sure that this happens. Stormwater runoff should be diverted from the roof to the site drainage system. Avoid garden beds butting up to the house unless they have excellent waterproofing against the waterproof membranes to prevent it getting that moisture seeping through the building envelope. Construction phase. Make sure you don't install wet building materials and make sure they dry before enclosing them. I mean, you know, one of the first audits we did was of a home, of an apartment in St Kilda made of tilt-up slab concrete, and there were stalactites growing in the car park. There was so much moisture coming out of the concrete because it hadn't been allowed to cure. Now, each square metre of concrete slab has around 210 litres of water. 90 litres of that needs to evaporate. So if the slab doesn't cure in time, then that water gets into inside the home and creates high levels of humidity. Of course, if that hits 70% or more regularly, you're going to have mould related problems in the house. So moisture sensitive materials like stick timber frames should be protected from the weather, but at the same time, if they're enclosed in plastic and they're already moist, it's going to create condensation and mould. Most timber frames, unfortunately, come on site already contaminated with trichoderma or fungi because they're left wet outside, and that's a problem. Concrete slabs and masonry like stone needs time to cure, and don't obviously apply any waterproof membranes to stone or masonry or concrete until it has cured. Make sure you sequence wet construction and finishing trades like slab and screening, plastering and tiling to allow the longest drying time as possible. Provide temporary dehumidification in the home, especially if built in warm, temperate and humid climates like the Central Coast, Queensland, Far North Queensland, Northern Territory, etc. That temporary dehumidification is essential before they put in the air conditioning system. The air conditioner, of course, is a dehumidifier. Inside, make sure the new builds in mild and cool temperate climate zones are well ventilated to allow time to dry. In Melbourne, for example, right now it's 34% humidity. Really dry here, it's too dry. So we need some form of humidification, but of course it's going to be opposite in the Central Coast of New South Wales and in Far North Queensland, where you want to keep your humidity levels around between 40 and 60%. So in Melbourne, when you're building, opening windows can be a good idea to help dry the home. Obviously not a good idea in humid climates. Exhaust steam from wet areas should be exhausted to the exterior, as I mentioned. Use hygroscopic building materials that can absorb and release moisture, whose surface temperature is similar to the air. Now this is why metal and stone is generally not recommended inside the home, and sealed timbers not ideal. Timbers that are breathable, paints that are breathable are so important, because if they are the same surface temperature as the air, then of course you're going to save a lot on heating and cooling costs, and the risk of developing condensation and mould is almost negligible. Again, the use of vinyl, which is impermeable to moisture, is a disaster. It emits phthalates, which is a hormone disrupting chemical, which I'll talk about later, it's a huge problem. Inside tips: adequate waterproofing. Make sure the builder does the waterproofing adequately. You know, I was there literally watching when we renovated our bathroom and our laundry to make sure the waterproofing was on really thick and that every surface was covered. Really, really important. Of course, the waterproof membrane doesn't last forever, and in old homes, eventually you get breaks through the waterproofing and it wears and it degrades and deteriorates. That's why you need to renovate and replace those waterproof membranes. I mean, it's unfortunately in older homes, that's just the reality of it. Vapor barriers that are intelligent, that can be hygroscopic, that are familiar with the microclimate and able to adapt based on the humidity and temperature of the climate are really important, and Raf will talk about those in the building material subjects, which you've already listened to. They need to be specifically appropriate for the microclimate of the area. Adequate insulation, always important. In Melbourne, it's very common to have condensation and mould related problems on the south side of the home, and this is often because there's no insulation and there's only single pane windows and there's not much sun on the south side, which means you don't get a lot of evaporation, and of course you get moisture sitting there for a long period of time. Double glazed windows can be important. Otherwise they can act as a thermal break and they're cold. Braided water hoses are notorious for leaking. So any form of braided water hoses, very important to check, you know, under the sink, under the laundry trough, because you'll find that they only are designed to last about 7 to 10 years. And, you know, once they break, they can cause a massive amount of plumbing and flooding issues. So it's important to make sure people do replace them in their dishwashers, their washing machines, and of course under the kitchen sink. Here are some problematic roof constructions. So you've got, in fact, every type of roof construction is there. We will go into more detail on that in the mould testing course. But, you know, with gable and hipped, you've got sun coming onto one part of the roof but not the others, so you don't get as much evaporation. You get colder surfaces on the other type of the roof. Stepped gable can be a problem, especially if the builder fails to put insulation between the different roof lines inside the building. That can be a real problem and cause condensation there. Skillion roofs can be a problem depending on if they, you know, if they're north facing, great. If they're not, that can be a problem because they can get quite cold. Low pitched parapets, flat roofs are a disaster. Let's just say that. For condensation and not for condensation, but for water leakage and plumbing issues and water pooling on the roof and then getting in under the flashing and gutter issues. You know, flat roofs are a problem. Just, you would not encourage anyone to have a flat roof. Double lean-to roofs can be an issue because one roof gets a lot of sun, the other doesn't get much, leading to cold surfaces. And of course, butterfly roofs and internal box gutters are a real problem for moisture hanging around. And of course, if there's any leaks, then of course they can come inside the home. Roof and wall tips. Install permeable vapor barriers and wraps or sarking. Vapor barriers in the roof are referred to as sarking, in a way that they are at a distance or air gap from the batten so they don't make contact with the walls or the roof. Really important. Big reason why they had in this study why they found condensation and mould problems. Avoid thermal bridges across framing members. Avoid internal box gutters, as I've mentioned. Eaves are absolutely essential to protect the walls from the weather, so having no eaves is a disaster. Flashing around structures should be done adequately and by a licensed roof technician or plumber, really important. Balconies built into the roofs, so we have a balcony with a floor below, notorious for leaking because the vapor barriers are only, and waterproofing is only designed to last for about 7 to 10 years. So ideally that balcony should be pulled up and then re-waterproofed. They are one of the first things we look for when it comes to mould related problems and water damaged buildings because they are notorious for leaking. Install capillary breaks and weep holes to prevent water coming into the home. That is a requirement of the building code. Reduce the build-up of water vapour. Now this is where the clients can make a big difference to preventing condensation. Water vapour in the house, every person will contribute about 5 litres of water vapour into a home every day. So the more people in the house, the more water vapour because of their bathing, washing clothes, cooking, breathing out, etc. So it's important they dry wet clothes outside, especially in areas like Melbourne where it's dry, or in a condensing dryer. If the dryer isn't a condensing dryer, then it's going to emit huge amounts of humidity. That humidity should be vented to the outside, really important. So ask the client, do they get condensation in the laundry? Well, then ventilation is a problem. They need to open doors, windows, or at least get a plumber to get some duct work and pull that to the outside. So at the design stage, you'd make sure that they get a condensing dryer or, vent it to the outside. Hang wet towels, don't leave them on floors in bathrooms. Use the exhaust fan. Clients can have a great exhaust fan, but they don't turn it on. So you might want to switch where every time the light's on, the fan goes on for X amount of minutes. It's timed to ensure that it is used when they're bathing. Of course, if you have any flooding or spills, you must mop it up within 24 hours, because within 48 hours the microbes on that surface are going to have a field day, and they're going to start out competing one another to take over that space and release endotoxins, mycotoxins and microbial volatile organic compounds. Use a dehumidifier if the home or the microclimate of area regularly exceeds 70%. So in the Central Coast where it gets cool in winter, I would strongly suggest they have a whole house dehumidifier that pulls moisture out to keep the humidity levels below 60%. In far north Queensland, they have the air conditioning on 24/7 all year round. Well, that's good because the air conditioner will pull the moisture out of the air to keep that humidity levels below 60%. The fourth principle to think of when designing a healthy home is to minimise exposure to electromagnetic fields. As I mentioned, we will cover this at length in the electrobiology subject. First, locate the smart meter panel away from the home, ideally at the front of the property, so it's not on the home. If that's not viable, then a garage may be appropriate, providing it's not near a living space or a bedroom. Appliances that generate high AC magnetic fields, which is generally anything with a motor, like a fridge, an oven, for example, they should be at least 1.5 metres away from where people spend time, especially the bedroom. So not having a bedroom backing up onto the wall of the kitchen where the oven is or where the fridge is, because along that wall you're going to have high AC magnetic fields when the fridge is cooling and when the oven is heating. Routers should be avoided. Wireless routers are just huge levels of radio frequencies. Many of the new routers coming on the market emit the same type of radio frequencies, the power output, as a mobile phone tower, and we're getting a lot of concerns about headaches, fatigue, skin rashes and things like, headaches will be one of the most common causes, and fatigue with people exposed to radio frequencies, sometimes palpitations. If they insist on having a wireless router and cordless phone, make sure they're away from bedrooms or where people spend time. They should always be turned off when they're not in use, especially the router, because it's designed to beam across the entire house. Make sure you power it down. I've got lots of tips in my book, and of course the electrobiology subject. Avoid running cables on walls where the bed heads will be. That would be ideal. Ideally, you should run cables along the top of the ceiling, because that's further away from where people are rather than through the subfloor, and then having these wires coming out to the bedrooms rather than having this spaghetti wiring all over the house. A demand switch can be quite useful in the fuse box. That needs to be installed by a licensed electrician, preferably someone who has experience with this, in order to shut down the supply to the circuit of the bedroom to make sure it's electrically neutral when you're sleeping at night. Bundle wires to cancel out the AC magnetic fields is good when they're bundling the wires, say, down the ceiling. Run wiring in the ceiling cavity, as I mentioned. Shielded paints and materials always used as a last resort, because they don't effectively get rid of the radio frequencies and they can't be used for AC magnetic fields, but they do have a place. Fifth, minimise exposure to chemicals. I've gone into detail on that in the book, but at the design stage, using not just low VOCs, it's the semi-volatile organic compounds that are a problem. And unfortunately, your base paints and sealants will often be low VOC, but once you add the tints and the additives, the VOC content explodes and they become high volatile organic compounds, and unfortunately they don't tell you this. So that's why we have a list of companies we recommend on my website, buildingbiology.com.au. Under the links section, I have a list of suppliers I recommend that provide relatively good quality paint sealants and glues with low levels of semi-volatile organic compounds. Use products low in semi-VOCs. Polyurethane floor lacquers should be always avoided. They're incredibly toxic. Particle board, not recommended, high often in formaldehyde and other chemicals. Vinyl is a disaster for human health. High phthalates, hormone disrupting chemicals linked with breast cancers and other endocrine disrupting problems. Rubber flooring, again, if it's not natural rubber, it can be a huge problem for petrochemical additives. Maximise ventilation, at the design stage when they're constructing it, open up the windows to enable those chemicals to outgas. I've talked about the use of bake out in my book, so I'm not going to discuss it here. You'll have to read that in that chapter. 6, heating, ventilation and air conditioning systems that are suitable for allergy sufferers. Now, radiant heat is far preferred to convection heat. Convection heat blows heat around the room. They are your ducted heating vents, for example. Radiant heat can often be more expensive because you're using your panel heaters, your hydronic floor heating. Don't use electric floor heating, it should always be hydronic. And it radiates the heat, it keeps it warmer for longer periods of time. It can take longer to heat up initially, but if you design your home in a way that you maximise, in Melbourne for example, northerly sun and reduce the exposure to the west sun that's setting, then often you don't need a lot of heating in the home because it should be able to maintain good relatively temperature all year round. But radiant heat is definitely preferred. More detail of that is available in my book. Gas appliances are a problem if they're unflued. Unflued gas appliances emit noxious gases like nitrogen dioxide, carbon monoxide, carbon dioxide, and of course carbon monoxide can be cause death at high levels. So gas appliances can be useful, however, make sure that it's flued really good, that the exhaust air can be exhausted adequately. Wood-fired heaters are a problem. I love my Canaras, but because it emits beautiful radiant heat, but someone has to put the wood in and take it out and get rid of all that coal and the ash, etc., which is known carcinogens. They contain polyaromatic hydrocarbons. So someone who doesn't have allergies, whose health is robust, they could empty and clean out the Canara, the enclosed heater. I love that sort of heat, but it's not good if you've got asthma or allergies, and of course the person who has to clean it out is going to be exposed to that. So they should wear a mask, put it in a garbage bag and put it straight out. Wood-fired heaters that are open fireplaces are a no-go, absolutely not recommended on any level as a building biologist. If people do have them, maybe use them once, twice, 3 times a year max, because of course, you backdraft that toxic gases into the living space. That's a real health concern. Evaporative versus refrigerated cooling. Evaporative cooling is good for climates like Melbourne, which get really dry. It can make it quite humid inside. With evaporative cooling, you need to open up a small amount of windows for every room you want the cooling to go through. I love the fact that you draw in fresh air and pull it throughout the house. Refrigerated cooling are normally your split systems. They're on a wall. They actually cool the air. They're far more effective. They are incredibly expensive to run, and they are susceptible to condensation and mold related problems on the fins, the blades, the condensing coil and the evaporator. You must encourage a client to get someone to clean their evaporative cooler and refrigerated air conditioner or split system at least every year, preferably before the heating season, before you put it on, because they are one of the #1 causes of generating mold spores and mold related problems in a home, so they should be checked. Encourage passive heating and cooling. I've mentioned if the house is designed in a way like in Melbourne that maximises northerly sun, reduces exposure to the westerly heat, having your utilities on the west side, your living spaces on your north side, your bedrooms on your east side, that's ideal, and that reduces the need for heating and cooling. Of course, in Queensland where it's really humid, using timber that is not sealed like your Queenslanders are brilliant in that environment, with very good eaves, good subfloor ventilation, timber that can breathe, cross ventilation because of the location of windows that enable the wind to flow through the home. Your Queenslanders are amazing in the ability to adapt to a high humid climate, and I'm always amazed at how cool they can keep the house in a really hot, humid temperature environment without the need of air conditioning a lot of the time of the year. Lighting. Big part of that. In the book there's a great table on the different forms of lighting and what we recommend as a building biologist. Natural light is always preferred over artificial light for obvious reasons. Natural light stimulates our circadian rhythm, it stimulates production of serotonin, really important for our hormones and our immune system and for our health and for vitamin D, blah blah blah. Illumination and colour of the home and the paints used should mimic nature as much as possible. Lighting should not be a source of high electromagnetic fields, and yet you'll find things like your compact fluorescent light bulbs are very high in radio frequencies, UV light, magnetic fields if there's a transformer in them, can be a huge problem. And of course, if they're broken, they can release mercury vapour. I find it astounding that we have this green movement that allows, these energy efficient devices to replace things like the incandescent light bulb, which is considered to be the healthiest form of lighting after sunlight. So the incandescent light bulb has now been banned because it's not energy efficient, and we've replaced it with something that if we break it, we shouldn't even be in our home. We should ring the council and get people with Tyvek suits to remove it. I mean, it's just lunacy. And many of these compact fluorescent light bulbs are people with electrical sensitivity cannot live in a home with these because of the electromagnetic fields that it emits and the dirty power. It shouldn't contribute to environmental waste, and yet how do you get rid of these compact fluorescent light bulbs with mercury vapour? I mean, we just don't think through a lot of these policies. Sunlight always preferred, and incandescent light bulbs are preferred. LED are will definitely better than your compact fluorescent light bulbs, so they may be an option for task lighting. And the last of the principles for healthy buildings is integrated pest management. I do go into this in detail in the air pollution subject and also in my book. The primary focus should always be don't attract the pests to the site, so don't have food and water lying around. Don't have places where they can shelter, like clutter around the house or inside the house where your spiders and your pests will want to congregate. And of course, create a physical barrier so they can't get in. At the design stage, you've got physical barriers like Termimesh and Granite Guard, which can be used instead of chemical pesticides. For a list of great websites that use non-chemical means for pest management, they include pesticide.org, pesticideinfo.org and beyondpesticides.org, which are also listed in my book. Thank you so much.